and he's director of the Institute for Memory Impairment and Neurological Disorders. And so he's been a major pioneering researcher in this field for quite a while. And I know he's going to have a lot of very impactful things to share with us this morning. Let's bring up Professor Ferla.
So thanks. It's a great honor for me to be here. I don't think I can't remember any time when I laughed so much at so early in the day. So it's a great honor. So I want to thank Brooke and my host Arlene. It's been great having breakfast and meeting a lot of very interesting people here today. And it's funny that we started off with a joke, and I guess I'll start off with two Alzheimer's jokes. One's actually true. My parents and grandparents are from Italy, and they were immigrants, and like almost all immigrants, they wanted their offspring to be either doctor, lawyer, or engineer. Those are generally one of the three things. And so my parents were very disappointed when I didn't become a doctor and I became a scientist. But then eventually my mother was very proud that I started working on Alzheimer's disease, except that with her broken English, she thought it was old-timers disease and not Alzheimer's disease. And that's and unfortunately, a lot of people have that same experience, but that's 100% true in my situation. And then my one Alzheimer's joke that I'll tell you, and this is sort of reflective of what goes on in the disease, and Alzheimer's is the second scariest disease for most individuals behind cancer. And so a gentleman goes to the doctor, and he's worried that he has Alzheimer's disease because every time he goes to the bathroom, afterwards he forgets to zip up his pants. And the doctor says, "Oh, don't worry, that doesn't mean you have Alzheimer's. It means you have Alzheimer's when you forget to zip down." And so now, we laugh about this, but Alzheimer's disease is the only medical condition that I know about where the initial diagnosis actually begins as a joke. You do something very goofy, you forget to turn off the burner, you go out naked to pick up your newspaper, things that are completely out of character for you, and that's what happens. One of your family members says to you, "What's the matter with you? Do you have Alzheimer's disease?" So there aren't many other medical conditions. No one ever jokes to you and says, "Oh, do you have cancer?" Right? But they do joke to you about saying whether or not you have Alzheimer's disease. So anyway, that was just a lighthearted moments, and let's just get a little serious now here and talk about what Alzheimer's disease is and what dementia is, because I hear from a lot of people that my loved one doesn't have dementia, they have Alzheimer's disease. And I'm here to tell you that dementia is an umbrella term in much the same way that cancer is an umbrella term. If you tell someone that you have cancer, that doesn't indicate whether or not you have breast cancer or lung cancer or skin cancer. And so dementia is equivalent to cancer. It's an umbrella term. And there are many different causes of dementia. There are some dementias that are reversible. So for many college students, on Friday nights when they go out drinking and on Saturday morning they have a reversible dementia. And we're really not concerned about that. We're really mainly concerned about the irreversible dementias, and in particular, Alzheimer's disease, because it's the most common cause of dementia. Not all causes of dementia are due to Alzheimer's disease, but almost all dementias, about 70% of them, are caused by Alzheimer's disease. And there are other forms of dementia. So there are dementias with Lewy bodies. This is a form of dementia where the person has a mixture of Alzheimer's disease and then Parkinson's disease. So they also experience a lot of motor problems and a lot of hallucinations. Other dementias are things like frontotemporal dementias, which affect the frontal part of the lobe, and these individuals suffer from disinhibition. That is, things that they would normally not do or not say, they no longer control those inhibitions, and they do them. So that's what I mean when I say someone might go out and pick up the newspaper naked or insult someone in public. Some people are very good at doing that chronically, but some people are not, and then they become that way, so sort of like a Tourette's syndrome. There are also individuals who are diagnosed initially with Parkinson's disease, and then as that disease progresses, go on to develop Alzheimer's disease as well. So it's sort of a double whammy. Now, Probably everybody in this room is used to using a computer. And you know how much havoc is wreaked in your life when your hard drive crashes. Imagine what happens to you when your body's hard drive, your brain crashes. That's what Alzheimer's disease is all about. You don't know anything about the other person, but yet they know everything about you. And that is a very scary situation to find yourself in, where you don't know someone who knows very intimate details about yourself. Okay, your memories are the core of your humanity, and they're what allow you to be the human person that you are. And this is a disease that comes in and destroys that, essentially, your soul, your memories, the things that you hold precious in your life. Now, one of the questions I frequently get asked all the time is, oh, I drove my car to the mall and I forgot where I parked my car. Does that mean I have Alzheimer's disease? No. Okay? And the reason for that is that a lot of things affect your memory on a day-to-day basis. Lack of sleep, taking the wrong medication, stress, all of these things can affect your memory. Now, if you forget you drove your car to the mall, then that's a little bit more severe. So what are we talking about in terms of memory tests? Here's a simple test that is frequently given to patients who are worried about whether or not they are suffering from a memory impairment. So all of us in this room learned how to draw a clock by the time we were in kindergarten. And so we'll ask a patient, draw a clock, and in this case, indicate the time as being 8:20. And there's an exam that is given to these patients called the mini mental state exam. And it's a very simple exam. It goes from 0 to 30. 30 means the person does not have dementia. And the questions are, tell us what state you live in, what year are we presently in, who is the president of the United States, who's the governor. Very simple questions. And so a score of 30 indicates that the person is not demented. And you could see this individual is able to draw a very nice clock. But now, as you could start to see people migrate into Alzheimer's, here's an individual on panel B that has mild stage Alzheimer's disease, and you could see that their clock is not as nice as the person who's not demented, and they don't even know to indicate how to put the little hand and the big hand on the clock face to indicate the time, 8:20. And they're very clever and came up with the strategy of actually writing the time of 8:20 right there. But now look what happens as individuals progress further into Alzheimer's disease. Here's an individual with moderate to severe Alzheimer's disease, and you could see that they don't even know to put the numbers inside the clock. Individuals with very severe Alzheimer's disease will actually sometimes just draw a straight line, and that's about as far as they can get. So Sydney, can I get the microphone for here? So how do I convey to you what it's like to interact with a person with Alzheimer's disease? It's there? Oh, okay, great. So I have a video that I put together or snipped together from a recent documentary that was shown on HBO. And so I hope there are no lawyers in the room because I probably violated a lot of copyright laws in doing so. But I think it's a very powerful video. It's only 90 seconds, and it shows you 3 women. The first woman is a little bit more advanced, and she is actually looking at her own reflection in a mirror, and she doesn't even know she's talking to herself. She thinks she's talking to another lady, and she asks the lady in the window, meet me out at the door, and she's really frustrated because she's always kept waiting for her reflection to show up. Second woman is asked to identify former President Bill Clinton, and despite a lot of prompting, is unable to do that. And it's always funny when I mention that because the Republicans in the room always say, oh, I don't blame her. And then the third woman was just asked to conduct a driving test, and when they asked her to turn right, she would go left, she would crash into things, and she was just informed that she lost her driver's license. And you could see her reaction there. So the sound system is is not as advanced as we would hope, so you have to listen a little closely, and I apologize for that.
She looks like you. I think she looked like you.
She didn't say anything to me.
Maybe it takes her time to say something.
Oh, I don't know. I'm tired of talking to her through the window.
want to meet her face to face
No. I
today?
tell many of the time, your door, and I'll be at the door.
Mm-hmm.
And you know, she had me wait there, and she never came out. Look at this. It's a snake. Does anybody have a knife? Where it is? Here.
There's nothing there, Yolanda. It's not a snake. You know, I'm telling you, right, it's not a snake.
You try to make everything simple, but you can't. You can't.
I think I can see his face, but I can't think his name.
It's Bill Clay. Starts with Clay. Not common, huh?
Right.
Okay. Really, what you all are telling me is that I have lost my independence.
So this is what Alzheimer's disease really does to individuals and ultimately to their families. It's not a disease that just affects one person, but it does affect an entire family and ultimately an entire society. And here's the latest statistics that just came out in September that describe what the impact of Alzheimer's disease is throughout the world. And it's a disease that mainly affects people in developed countries because they generally have better medical care and live longer. But there are right now worldwide over 35 million people suffering from Alzheimer's disease. By 2030, that number is going to grow to 65 million, and by 2050, that number is going to grow to about 115 million. We estimate that to care for patients just within the United States over that time period is going to cost about $20 trillion, and that's trillion with a T. Now, what about in the United States? Well, right now, someone develops Alzheimer's disease every 70 seconds in the United States. By 2030, that number is going to drop to someone developing Alzheimer's every 30 seconds. We have today over 5.3 million Americans who are suffering from Alzheimer's disease, not to mention the other forms of dementia that exist as well. So this is having a tremendous impact on our society. And it's a very costly disease. It's one of the most expensive diseases to treat and to care for. And it's conservatively estimated that right now we're spending about $150 billion to manage these 5.3 million cases. And that number is just going to explode, as I indicated. California is going to be particularly impacted because the baby boomer generations have, the first part of them just turned 65 last year. And so California is ranked first in the country in terms of the largest baby boomer population, and Orange County is ranked nationally as the 5th largest county in America with baby boomers. So this is going to affect us very severely in this state. Now, this next slide just shows you that Alzheimer's disease is an equal opportunity disorder that can afflict a lot of people from rich to poor, from presidents to common laborers. And you could see here some very famous individuals. And I always like when I show this slide, particularly when I'm lecturing to the undergraduates, because they have no idea who any of these people are, with the exception of Ronald Reagan. But in other audiences, they usually do. So here's Rita Hayworth. She was actually one of the first people who publicly announced that she had Alzheimer's disease. And her case was actually very interesting because, like so many people who suffer from these kind of disorders, people, when she was at the beginning stages of this disease, thought she was nuts. They thought she was drunk all the time and just a typical Hollywood starlet because they would find her wandering around. And so her reputation really suffered quite extensively as a result of it. We now know that that behavior was due to the fact that she had Alzheimer's disease. But there are many famous individuals on here. Obviously, Charlton Heston is on here. Maria Shriver's father is on here. Charles Bronson, Otto Preminger, who played Mr. Freeze on the Batman TV series, the Burgess Meredith, who played the Penguin on Batman, is also on here. So somehow being on Batman gives you a higher chance of developing Alzheimer's. But Rosa Parks, Perry Como, Iris Murdoch, Winston Churchill, Cyrus Vance, very, very famous people, people of significant wealth and also of significant intelligence. So this is a disease that can really strike anyone. And in California, we're particularly impacted, as I mentioned, because there are so many baby boomers here, but also because 10% of the Alzheimer's patients in the nation reside in the state of California. There are over 588,000 patients in California who have Alzheimer's disease. Just to put this in perspective, the second most common neurodegenerative disorder after Alzheimer's disease is Parkinson's disease, and there are about 500,000 to 1 million patients throughout the United States. So there are almost as many Alzheimer's patients in the state of California as there are Parkinson's patients all throughout the United States. And this number is going to double over the next 20 years. Latinos and Asians are going to find that the incidence of Alzheimer's disease in their group are going to triple, and that's reflective of the demographics within the state. Orange County is particularly impacted. There are 60,000 residents right here in our backyard of Orange County who suffer from Alzheimer's disease. 60,000. So this next slide shows you what's going to happen in terms of the growth in the general population in the state of California. It compares that to the Alzheimer's population. So if you look at this blue line here, over the next 20 years, you see that there's an anticipation that the general population is going to grow by about 20 to 30%, somewhere in this neighborhood. And that's great for people who are in the real estate market because it indicates that their property values should go up pretty substantially. But look what's going to happen in this line that's depicted by the orange curve here. And that shows the growth in the population of individuals with Alzheimer's disease. And you could see it's going to grow by almost 100%, which means it's going to double. That's within 20 years that we're going to deal with that. And if you think that Orange County is going to be spared, we're not. You could see that right now we rank third in the state of California behind LA and San Diego County regarding the impact that Alzheimer's disease is going to have on our local community. And again, as I indicated, that's mainly because we're ranked fifth nationally in terms of the having the most baby boomers. Now, we've made a lot of progress in medical science over the last 20 years, and that could be reflected here in this curve that shows you the death that are due to different disorders such as influenza, pneumonia, or cerebral vascular disease you could see is declining. Heart disease has declined. Chronic respiratory disease has declined. Diabetes has gone up in part because people are getting fatter, and obesity is becoming a problem. But look what is happening here for Alzheimer's disease. There's been a 60% increase in the state of California in deaths due to Alzheimer's disease. And that's really scary, particularly since most of these Alzheimer's patients end up dying because of pneumonia or asphyxiation. They forget how to swallow, and food, instead of going into their esophagus, goes into their lungs, and they eventually drown from asphyxiation. So how do we get to where we are today with Alzheimer's disease? And we can actually trace our roots back to this gentleman named Alois Alzheimer's. And he was a German psychiatrist and actually wrote a paper that has become very famous, and we actually celebrated the centennial of Alzheimer's disease about 3 years ago. And his paper at that time was called A Peculiar Disease of the Cerebral Cortex. It was called peculiar because it wasn't considered that common. As a matter of fact, a lot of individuals who went to medical school as late as the 1980s were told that they would probably never see a patient with Alzheimer's disease in their lifetime. And can you imagine saying that today? I mean, it's just insane given how common it is. So his patient that he analyzed was this woman here that we now know is Auguste Deter. And she was a relatively young woman. And you could see from this slide that she does not look very healthy. You could see from her body posture how withdrawn and sullen she looks. You could just see the empty expression on her face. And that's what it means to have Alzheimer's disease. She was actually a relatively young woman for the period. She was only 51 years old when she was diagnosed with Alzheimer's disease. And she was actually brought into Dr. Alzheimer's clinic by her husband because he was so frustrated with the fact that she couldn't remember her name anymore or how to prepare dinner. And she had this rabid jealousy of her husband. She kept thinking that her husband was cheating on her. Turns out he was. No, I'm kidding. Dr. Alzheimer's analyzed her and would ask her very simple questions. What is your name? And she would say, Auguste. He would ask her what her last name was. She would say, Auguste. He would ask her what her husband's name was. She would say, Auguste. So he was very fascinated by this woman. And even though he moved away from the city in which she was, he continued to follow her. And when she died, he had her brain sent to her. And I'll show you on the next slide what she found. But I think besides being the first patient that we credit with Alzheimer's disease, and we know that throughout human history that she's not the first person to have Alzheimer's disease, but she's the first person that we credit with this disease. She actually described the disease, I think, in a very meaningful way that is very apt even today. And she says, I have lost myself. And that's what this disease is all about. Now, when she died, Dr. Alzheimer's examined her brain, and this is what he found. He found that there were 2 lesions that existed within her brain. The first were these structures that were called plaques, and they look like Brillo pads that just get deposited in regions of the brain that are involved in learning and memory. And you could see how ugly these structures are. And they actually consist of a very small protein that's called beta amyloid. The second lesion he described actually occurs within neurons. These are your nerve cells in the brain, and they consist of a protein called tau that gets twisted around itself and so forms tangles in much the same way that your hair can tangle up. And you know how painful it is when you have to comb your hair and you have a lot of tangles. Imagine what it's like for your cell when you have a lot of these tangles that accumulate. It blocks the transfer of information and nutrients from one part of the cell to the other. So even though he described these over 100 years ago, today a diagnosis of Alzheimer's disease is only presumptive while the patient is alive. It's not until they die and that you see these structures, plaques and tangles, can you say definitively whether or not a patient had Alzheimer's disease or not. Okay? Now, that will probably change over the next 5 to 10 years as we develop better tools for in neuroimaging, and hopefully we'll be able to diagnose the disease better in individuals while they're alive. But as of today, it's not until the person dies and you count their plaques and tangles that you can say whether or not a person has Alzheimer's disease. And that's because a lot of the dementias sometimes bleed over, and one form of dementia may look like another. But it's not until they die that you can say for certainty. Now, plaques and tangles are by definition what Alzheimer's disease is. And so what my lab here at UC Irvine was trying to do was try to mimic this feature of plaques and tangles in mice. And you might ask yourself, why would you study a disease as complicated as Alzheimer's disease in mice? And there are actually several reasons for it. One is mice breed pretty quickly, and they age over a short lifespan of 2 to 3 years. And that's important because we can't wait and study this for 80 years in people. Their brain organization is similar to what you find in humans. It's not identical, but it's close enough. Turns out that many genes and proteins are actually conserved, believe it or not, between mice and humans with only very, very subtle differences. And then I put this next part in quotations. It's relatively cheap to study mice compared to humans. And I say put cheap in quotation marks because many of you may not know this, but the university actually charges me a hotel bill for maintaining these mice, and our hotel bill is about $35,000 a month just to house these mice. So it turns out that I'm the largest user of mice on the UCI campus. We have about 6,000 of these mice in our colony here, and they are very expensive to maintain. Rats are actually double what they are for mice, believe it or not. So that's why a lot of people do experiments with mice. You can actually house 4 to 5 mice in a cage, provided that the mice are not all males, because the males tend to fight if you didn't put them together from early parts of development. But rats, you're lucky if you can get 2 rats per cage, because they're so much bigger than what a mouse is. I mean, some of the rats here almost the size of possums. So they're very, very big. But what's nice about mice is that there's been a lot of technology that's been developed over the last 30 years. So it's very easy to put human genes into mice and to have those genes produce proteins that are expressed in the brain. And so what we have done in our lab is to take genes that we know cause familial Alzheimer's disease with an early onset. In some families, they can get Alzheimer's disease as young as 16 years of age. Most people with early onset Alzheimer's get it in their 30s and 40s. And we could take those genes that leads to the most aggressive form of Alzheimer's disease and put them into mice and have the mice develop some pathology. And so from that, we can then study disease processes, and because we could simply sacrifice the animals and study the different stages, which obviously you can't do that with humans, and we can evaluate a lot of new treatments in the mice to see which work. So these provide important preclinical data. And so here's what the mice look like pathologically. They develop plaques, which are shown here in green, and tangles, which are shown here in red. And this is the first mouse model to this day that develops both plaques and tangles. And so most people think of these mice as being the gold standard for the field. And the university, for a long time, this was actually the second largest moneymaker for the campus, because they would actually license these mice to big pharmaceutical companies for about $500,000 for breeding pairs. So very, very expensive mice, and usually I tell a lot of people that, and they're like, I have mice, I can give them for free. But the mice not only develop pathology, but importantly, develop memory symptoms as well. And they develop it in an age-related fashion. You could see in just a simple test, and I'll explain a little bit later how we measure some of these things. But what's important to see here is that they develop, their memory function declines as the mice get older, and we can attribute the decline to different stages. So as you can see, these mice are incredibly valuable, and as a result, there's been a large demand for these mice. And we've actually sent the mice to academic researchers free of charge, and we've sent them to over 150 investigators in over 20 countries. And it's actually, within the United States, pretty cheap to send the mice to other investigators. Only costs about $150 to $200, and everyone is very generous, and we ask them to reimburse us for the cost, because when the first person requested the mice, that was one person, so we sent the mice. It wasn't worth doing the paperwork. But then eventually started getting to be a very large number of people who were requesting these mice. And believe it or not, I still get on average about 5 requests a month for these mice, even though we made them in 2003. However, to send them out of the country is very expensive, on the order of $2,000 to $3,000 a pop. And there's a lot of legal issues because they have to clear customs, and a lot of issues there. Now, what are some of the risk factors for Alzheimer's disease? Well, the most important risk factor is age. Alzheimer's disease, like many of the neurodegenerative disorders, is an age-related disorder. You may not know how severely age impacts it. 1 out of every 20 people, which means 5% of the population over the age of 65, has Alzheimer's disease. And that number doubles every 5 years thereafter. So if we do the math together, that means 1 out of every 20 people over 65, 1 out of every 10 people over the age of 70, 1 out of every 5 people over the age of 75, and 1 out of every 2 to 3 people over the age of 80 to 85. So essentially, half the population over the age of 85 is suffering from Alzheimer's disease. And you could see why California is going to be particularly impacted, because we have a large baby boomer population. So age is the most significant risk factor for Alzheimer's disease. And so I always tell people, if they don't want to get Alzheimer's disease, don't age. Now, there are other things that can affect your ability as well. And there are susceptibility genes and risk factor genes. And there's one gene that we know that increases your odds of developing Alzheimer's disease. However, the field does not do any genetic testing for that, because we don't really have a treatment if we tell you you have this gene that's going to increase your odds of developing Alzheimer's disease. So the field has decided not to offer that. If you have a family history of dementia, that increases your odds of developing Alzheimer's disease. Likewise, if you have sustained a previous head trauma, that markedly increases your odds. Just to show you how much that does, if you are a football player in the NFL, you have an 18-fold higher chance of developing Alzheimer's disease compared to anybody else. And so we often complain at how much money our sports players make in the NFL because they get these $1 million or multi-million-dollar a year contracts. And you have to ask yourself the question, if I give you $1 million when you're in your 20s and 30s and tell you that you play for us and the average lifespan in the NFL is, what, 4 years? And you take this money, you play in the NFL, and that will increase your odds of developing Alzheimer's disease down the road at a much earlier age than what someone else gets, 18-fold. Would you do that? And that's an important question. So another risk factor is Down syndrome. So it turns out that almost everyone with Down syndrome will go on to develop Alzheimer's disease by the time they're in their 40s and 50s. The reason for that is that that plaque protein happens to reside on chromosome 21. Individuals who suffer from Down syndrome have 3 copies of chromosome 21, and therefore they make 1.5 times the amount of the plaque protein compared to normal people. If you have a low education level, that puts you at a greater risk for developing Alzheimer's. The better educated you are, the lower your chances are of developing Alzheimer's disease.
Why is that?
So probably because education and intelligence is like having money in the bank. The more money you have in the bank, the better you're able to withstand recessions. And so the more intelligence and cognitive activity that you have going on, the more connections you have in the brain, and so therefore you're able to withstand the withering away of those connections as you get some disease processes. What's been interesting over the last 5 years, and this has come as a big surprise, has been the diet and environmental factors can play a big role. Now, think back. Maybe in the 1950s, when people were first making the connection between what you eat and heart disease, people thought that was insane. How can what you eat affect your heart when the heart is not connected to your digestive system? Now there's no one that doesn't doubt that if you eat steak every single day for dinner, that you're putting yourself at major risk for coronary heart disease. And it's the same thing for the brain. What you eat definitely affects your brain. And so there's been a lot of work, and a lot of it in our lab, that shows that diet plays a major role. So you want to try to prevent Alzheimer's disease, eat foods that are enriched in DHA or omega-3s. Things like salmon, for example, and other cold water fish. The American diet has changed markedly over the last 100 years. We did not eat as many processed foods, and ate a lot more natural foods and had a lot of omega-3s in our diet. Over the last 100 years, the ratio of omega-3s to other fatty acids has inverted. And so low omega-3s are not only linked to higher risk of developing cardiovascular disease, but also Alzheimer's disease. Now, what we have found in our lab is that if we give these mice omega-3s before they have Alzheimer's disease, that prevents the development of it. But if the mice already have Alzheimer's disease and we give them omega-3s, it has no effect. So it's very useful at the prevention. There are other environmental factors as well. So for example, we have found that smoking accelerates the development of the pathology in these animals. Stress also does the same thing. We can take 3-month-old animals, inject them with the stress hormone once a day for 1 week, and at the end of that week, those 3-month-old animals now look like 9 to 12-month-old animals in terms of their pathology. And just shows you how severe stress can be. So let's just focus on one of these and show you some of the experiments we've done. And in particular, we'll talk about low education level and why it's so important to talk about cognitive stimulation. So I already mentioned that people who are better educated have a lower chance of developing Alzheimer's disease. And education is a proxy for intelligence, because how do you compare someone who got a philosophy degree from Harvard to someone who may have gotten an engineering degree from some Midwest university? How do you evaluate that? We don't. It's impossible. But all education level is meant to be is a proxy because it's something that's easy to quantify. We can say that someone who had 18 years or 20 years or 22 years of education probably is smarter than someone who had maybe 12 years of education. But that's not always absolute. Is there anyone in here who's bilingual? So bilingual people have a lower chance of developing Alzheimer's disease because probably they engage multiple parts of their brain. I know from my own experience growing up, my parents never completed a sentence in the same language. They either started in Italian and ended in English or vice versa. As a matter of fact, when I was a postdoc, my uncle left a message on my answering machine, and a friend of mine was there, and he heard it, and he just looked at me and he said, "You know, you are so lucky that you're bilingual." He goes, "I really hate people who speak a second language. I always wish I spoke Italian that fluently." And I said, "Yeah, you're right." I said, "Except that message you heard was in English, not in Italian." and so I translated for him, which he couldn't believe. But anyway, a lot of what we have realized is actually, believe it or not, come from Catholic nuns. And that's because their community is a very closed community. They live in the same household, eat the same type of foods, engage in the same kind of practices, presumably avoid the same kind of risk factors. And so they provide as close to a homogeneous human population as you could possibly get. And what's been interesting is these women, when they were about to become nuns, had to write down a biographical statement about themselves. Those women who wrote very simple sentences without multiple clauses, such as, "Tomorrow I will become a nun," had a much higher chance of developing Alzheimer's disease compared to women who were 19 and 20 years old who wrote sentences that were very complex, that had multiple thoughts in them. Okay, this was 40 or 50 years in time. Okay, so it raises the question of, when does Alzheimer's actually begin? And we don't know the answer to that. So how do we study these in mice? So what we did to address this was we actually intellectually stimulated the mice multiple times. Now, how do you do that in a mouse? You can't go to a mouse and say, "Draw me a clock," like you can for humans. And in animals, memory is inferred. So we use a test called the Morris water maze. And this is a test where we put mice in a swimming pool, and we ask the mice to try to find a platform. And mice don't like to swim, and so they're hence very motivated. So this is different than a food-based test, because if you give the mouse a food-based strategy, you have to assume that the mouse is hungry, because if it's not hungry, it might not be interested in finding the food. And so to make the mice interested or hungry, you often have to starve them. And the nice thing about this Morris water maze is you don't need to do this. And so here's what it looks like. Here is the platform that's located below the surface of the water. you see that the mouse is swimming around, and it'll eventually bump into the platform. And once it finds the platform, it will use cues in the room to help it navigate. So this is the equivalent of a human trying to find their car in a parking lot. And if a mouse doesn't find the platform, we pick it up and actually put it on the platform so it knows where it is. And with time, the mice over 5 or 6 days eventually can do this task very easily, and they can find the platform in less than 20 seconds, such as this guy does here. And you could see that the longer it takes, we can use that as a proxy for memory. And obviously, the Alzheimer's mice can't really find that. So we tested these mice repeatedly. What we did was we started off with mice that were 2 months of age, test them again at 6, at 9, at 12, at 15 months of age, and compare them, for example, at 12 months of age to a mouse that was seeing it the first time. And here's what we found. The lower the bars are here, the better the scores. So essentially, the mice who saw the test multiple times did better. So you're saying to yourself, big deal. You give me the opportunity to take a test multiple times, I'll do better too. And that's true, except what we also found was that it also affected the pathology in these animals. Here's the 12-month-old animals that had just saw the test one time. Here's the 12-month-old animals that had seen it multiple times, and you could see that there are no plaques in the experienced animals. So by intellectually engaging these animals, we can reduce the pathology. Same thing was true for the tangle pathology. We could reduce plaques and tangles by engaging intellectually. That was the good news. The bad news was that experience only takes you so far. And so what we have found is that, yeah, there are profound difference at 2, 6, 9, and 12 months of age. But by 15 months of age, there was no longer a difference between the experienced animals and the naive animals. Now, that may be because we didn't test them hard enough, and we need to be much more engaged in what we're doing there, and we're doing those studies right now. So the bottom line from this is you want to make sure that you engage and use your brain as much as possible, because you want to perform activities that are very, very novel and that allow you to really play a role in engaging as many systems as possible. So I think with that, I will stop at this time point and take any questions that you guys may have. So,
About 5 or 6 minutes for questions.
okay, 5 or 6 minutes for questions.
Okay, thank you. This has been absolutely fascinating. Comment. I wouldn't want to be one of your expensive mice.
Oh.
And I understand it's for a good purpose, and I wouldn't want to be one of these poor guys swimming around in that wow. And question. We see from your charts how much Alzheimer's is expected to increase over the next 20 years, and that a good deal of that has to do with the baby boomers getting older, and so we have accelerated Alzheimer's. What portion of it is due to those risk factors other than aging? In other words, over time, is a 65-year-old more likely than in earlier times to get the disease?
So we have better diagnosis than what we had in earlier times. And if you probably recall back to your own youth, when you saw someone who was what we would call acting goofy or out of character, we often refer to that person as being senile. And we didn't actually know it was a disease process. Now we do know that it's actually attributable to Alzheimer's disease. Probably the rates of Alzheimer's disease have always been the same throughout human history. And we know that by far age is the overriding risk factor. The problem with doing the kind of studies that you're suggesting in humans, unlike in mice, is that in mice we can control each of those risk factors, but in humans you can't. So you don't know if a person is aging, You don't know whether they smoke, whether they drink, if they smoked earlier in their youth and they stopped smoking, what effect that has. So it's very, very complicated studying all of those parameters in humans. You know, the only thing that we know for certainty is that your risk of death is 100%. Nothing you do is ever going to alter that risk of death, right? It's always going to be 100%. The only thing that we can do is try to reduce your risk of developing Alzheimer's disease and trying to maintain a very high quality of life. Because what we really want to make sure is that Alzheimer's disease is not your reward for living a successful life.
Hello? Could you just discuss a little bit about the correlation between Alzheimer's and diabetes that we talked about on the table?
Yeah, so it turns out that there is a very strong link between diet and the chances of developing Alzheimer's disease. As a matter of fact, one of the best predictors of whether or not you're going to get Alzheimer's disease is what your midlife cholesterol levels are. So it's very important to do that. But diabetes also seems to play a role. As a matter of fact, some people have referred to Alzheimer's disease as the new type 3 diabetes, and probably because the insulin signaling pathways get altered in the brain, and that leads to the generation of more of the plaque protein. Now, an interesting aside, and there are probably multiple mechanisms by which diabetes and Alzheimer's are linked, but one of the strongest is that one of the enzymes that's responsible for degrading the plaque protein is called insulin-degrading enzyme. And it shows you that there's a very close relationship between Alzheimer's and diabetes.
Okay, here's the mic. Is there any correlation between the symptom presentation of the plaque versus the tangle?
So great question. And so there's been a lot of work done in the field, and it turns out that there's really not a direct correlation between plaque number and tangle. And that's because how do you measure plaque number? Well, you just count them. Well, how do you, these plaques are very amorphous and they come in different sizes. So some are the size of a baseball, some are the size of a basketball, some are the size of a tennis ball or a golf ball. How do you measure that? And so over the years, we've realized that it's not so much the actual number, but it's the content of that plaque protein. And in reality, it turns out that maybe the plaques themselves are protective. It's that precursor form before they get there that's the problem. So that's why those correlations are not very strong. But we do know that the plaque protein is the trigger for all causes of Alzheimer's disease, because everyone who has a familial version of Alzheimer's disease, the genes all are involved in affecting the metabolism of that plaque protein. Two more questions.
I'm dealing with two parents that have dementia, beginnings of, and maybe you didn't have time to touch on the subject of denial and medication.
So denial is obviously a very personal issue, and it's very hard for people to imagine that their brain is no longer working. Particularly, what's ironic about Alzheimer's disease is that their body, for the most part, is generally pretty good. And you'll see people, even like Ronald Reagan and Charlton Heston, who had very strong bodies and felt very robust. And it's very difficult to imagine that your mind is no longer working. What's also weird about Alzheimer's disease is that a lot of us think that the decline is very consistent, and it's not. What you see is it looks much more like a seismic plot. It's up and down. So patients have good days, they have bad days, and often those are in a mix. So some patients have a lot of lucidity, and then they go to moments of obscurity. And so that's why a lot of caregivers are often advised, don't talk to your parent or your loved one or your spouse as if they were a baby. And talk to them as in a normal way, the way you always interacted with them, because when they come out and they have a lucid moment, they become very frustrated and angry that they're being spoken to in a very childlike fashion. And so did I answer? Oh, medications were the second ones. There are a couple medications that slow the course of the disease to some extent, or are symptomatic. They don't really affect the disease course. They're not disease modifying. So it's analogous to the way you would treat a fever without necessarily affecting the underlying cause of that fever. And they work for a short period of time, in the best case, maybe 18 months.
I noticed that you didn't put as a causative factor strokes, and yet factor of particularly hemorrhagic
Yeah.
strokes is a type of dementia, and you don't consider that Alzheimer, or where does strokes fit into
So
this
stroke
whole
is
thing?
under vascular dementia, and that's a really great question. So one of the things that we're studying actually in our laboratory right now is the impact that stroke has on these mice and their probability of developing Alzheimer's disease sooner, and also the other question, which is whether or not having Alzheimer's disease increases your chances of developing stroke. So we actually are doing a lot of work in that particular area. There's a lot known about the connection between stroke and Alzheimer's disease. And the problem is with these individuals is that a lot of Alzheimer's patients, since they're older, don't suffer from just a single disorder. They actually have multiple illnesses going on, and we call those comorbidities. And so we are actively investigating how comorbid diseases impact the development of Alzheimer's disease in these mice and also correlating them to humans. So I think I have to go. So thank you very, very much. It was a great pleasure.